Hello बच्चों. The question is 1 mole of a real gas is subjected to heating at constant volume from P1 V1 T1 to PO2 V1 T2. Then it is subjected to irreversible adiabatic compression against constant external pressure of P3 atm till the system reaches the final state, that is P3 V2 T3. If the constant volume molar heat capacity of the real gas is Cv, then what is the expression for delta H for state 1 to state 3? And the options are Cv T3 minus T1 uh, and plus P3 V1 minus P1 V1, Cv T2 minus T1, P3 V2 minus P1 V1. Accordingly, the different options are given. So we have to look towards the question what he have been said. So first is your step 1. In the first step we can say that this is a isochoric process as the volume remains constant. So P1 V1 T1 is converted into P2 V1 T1. Okay, so it is at step 1, and at step 2 the P2 V1 T1 is converted into, sorry, this is T2, this is T2 is converted into P2 V1, sorry, P3 V2 T3. So we got two steps here. In the first step we can see that this is a isochoric process, and the second step is adiabatic compression, or we can say this is adiabatic compression. Okay, so accordingly we have to say which type of the what is the delta H. So for first step we have to calculate the delta U1, that is change in internal energy, and the change in internal energy can be calculated by delta U is equal to N into CBDT, and as it has been said that number of moles is 1 mole, hence N is equal to 1 multiplied by Cv, already it has been given, and dt is equal to will be T2 minus T1. Okay, so this is the expression for del U. Then what is the expression for del H1? That is the change in enthalpy in the first step. It will be your, we know that delta H1 is equal to delta U1 plus delta P into V, but here the volume remains constant, so you can say delta U plus P del P. So delta U we have already known that delta U is equal to Cv into T2 minus T1 plus V is equal to V1, and delta P is equal to your change in pressure, that is P2 minus P1. Okay, so this is delta H1. Further, this is the expression for delta H1, we can represent in equation 1. Then move towards equation number 2, that is your second step. So in second step, this is the second step, that this is the adiabatic expression. So for adiabatic, Q remains constant. Q is equal to 0 for a adiabatic process. That means U2 delta U2 will be equal to W2 work done, or you can say this is minus P external multiplied by V2 minus V1. Here the V2 final volume will be your V2 and initial volume was V1, and it was P external. In terms of P external we can write it as the pressure is your, as it has been said that at P3 atm A constant external pressure has been given, that is P3 atm. So we can see, we can put here minus P3 into V2 minus V1. Then further, this is the expression for internal energy. Then for expression for enthalpy, change in enthalpy can be calculated as delta U2 plus delta into PV, or you can say that minus P3 multiplied by V2 minus V1 plus delta PV means your, sorry, this is delta PV means P3, this will be equal to your P3 V2 minus P2 V1, right? P3 V2, this is P3 V2 minus P2 V1 minus P2 V1. Okay. So we got the expression for delta H2 here, and if we add both of them, that then we will get the delta H for the throughout for the total process. Delta H will be equal to delta H1 plus delta H2. Okay, so this will be your delta H, and delta H1 is equal to your Cv into T2 minus T1 plus it is your V1, then this is P2 minus P1, sorry, this is P2 minus P1 plus we can add this P3 V2 minus P2 V1 minus P3 V2 plus P3 V1. Okay, so both of them will be added, and accordingly if we multiply this V1 into P1, then it will be P2 V1 minus P1 V1 plus P3 V2 minus P2 V1 plus minus P3 V2 plus P3 V1. So P3 V2 and this is P3 V2 will be cancelled. Okay, and again P2 V1 and this is P2 V1 will be cancelled. So we will get the P3 V1 minus P1 V1. So the total enthalpy will be your Cv T2 minus T1 plus this is P3 V1 minus P1 V1. So P3 V1 minus P1 V1, Cv into T2 minus T1. Cv into T2 minus T1, option B, C are given, but P3 V1 minus P1 V1, that is option number C is the right answer. Okay, I hope you might have understood the concept of this question, that is option number C. Thank you and all the best.